students, we are solving the IB Math AA HL past papers, and currently we are solving the IB Math AA HL May 2021 paper 2 time zone 2 past paper, and today we will be solving the question number 8 of this paper. And you will be getting the links to all the previously solved questions of this paper and of the other papers in the form of playlists in the description area. So without any further delay, let us start solving question number 8. It contains a maximum mark of 5 and it doesn't have any subpart. Consider z equal to cos theta plus I sin theta, where z is a complex number, z is not equal to 1. Show that the real part of 1 plus z over 1 minus z is equal to 0. Okay, so first of all, let us get the expression for 1 plus z over 1 minus z. Okay, so 1 plus z over 1 minus z equal to 1 plus cos theta. I'll be writing cos theta plus I sin theta in place of c. Simple. Okay. And since 1 plus cos theta, this is the real part, I'm just putting a bracket around these two terms, and plus I sin theta. Over 1 minus z, so it will be minus cos theta minus I sin theta. So it is 1 minus cos theta minus I sin theta. Okay? And the normal way, what we do if we have a complex number expression in the denominator, we multiply with its conjugate. So we will be multiplying the numerator and the denominator by 1 minus cos theta plus I sin theta over 1 minus cos theta plus I sin theta. Okay. So this is equal to, see, 1 plus cos theta times 1 minus cos theta. This is a plus b, this is a minus b. So the product of these two will be a square minus b square, where a is 1 and b is cos theta. So I'm writing this as 1 square is 1 and minus cos square theta. Okay. And then I have to multiply this 1 plus cos theta times I sin theta. In fact, actually, we are interested in real part, but we can ignore this multiplication because that will be giving some imaginary part. But I am doing the total multiplication because there may be students who will not be realizing that we actually do not have to multiply 1 plus cos theta with I sin theta, because those will be the imaginary parts. Those will be the terms of the imaginary part. Okay, so you can very well skip that part. But anyway, I am doing the entire multiplication. So it will be plus I sin theta and plus I sin theta cos theta. Okay? And this will be, now we will be multiplying with I sin theta, the whole of this part. So it will be plus I sin theta and, okay, let me just write the entire numerator. It will not be fitting in this line. I sin theta and then minus I sine theta cos theta, and then I sine theta multiplied by I sine theta will be I square sine square theta, and I square is -1, so it is minus sine square theta. Okay, this is the entire numerator. This should be divided by, because now I'll be multiplying the denominator terms. So I have bracketed all the terms of the numerator, and all the terms of the numerator should get divided by the terms of the denominator. So I'm putting the bracket, and over here you see 1 minus cos theta, and this is also 1 minus cos theta, and this is minus I sine theta, this is plus I sine theta. So it is basically A minus B times A plus B, where A is 1 minus cos theta and B is sine theta. Okay, you can just go on multiplying term by term, but if you visualize this relation, the identity, right hand side of the identity, or you may call it the left hand side of the identity, because it is the equal to sign, doesn't matter which side you are considering. So it is A minus B times A plus B. Therefore, the product should be equal to A square minus B square. Okay. So this will be, let me put this square bracket. A square is, A is 1 minus cos theta, so it is 1 minus cos theta whole square minus B square. B is I sine theta. So it is minus I sine theta whole square. So this is the denominator. Okay. Let me come over here now. So this is equal to, can we cancel anything? First of all, let us just separate the terms, the real part and the imaginary part. So we are first of all writing the real terms of the numerator. It is 1 minus cos square theta, and then these are all containing i's, and this is minus sine square theta. We are having only 3 terms from the numerator which do not contain I, so I have written that. This is divided by 1 minus cos theta whole square. 1 minus cos theta whole square is definitely a real expression, doesn't contain any I, but you may be confused over here for this term I sine theta. Is it an imaginary expression? No, it is not, because it is getting square, so it will be I square sine square theta. And what is I square? I square is -1, and you are having this -1 in front, so it will be minus of sine square theta, which is plus sine square theta. This is the denominator. I don't have to expand 1 minus cos theta whole square, because they have only asked us to show that the real part is equal to 0. Okay, this is the real part. Let me write the imaginary part as well. I, and from the numerator I am having sine theta, this one. Oh, it is 2 I sine theta, I can take sine theta. Okay, and actually I sine theta and minus I sine theta, I sine theta cos theta and minus I sine theta cos theta, these two will be getting cancelled. So it will be simple plus I 2 sine theta over the same denominator 1 minus cos theta whole square, plus sine square theta. So this is the real part and this is the imaginary part. Now we come to, therefore, real part of 1 plus c over 1 minus c equal to 1 minus cos square theta minus sin square theta over 1 minus cos theta whole square plus sin square theta, and if I combine these two, second and the third terms together of the numerator, I get 1 minus cos square theta plus sin square theta, which should be equal to 1, over 1 minus cos theta whole square plus sin square theta equal to 0. Because you can write another step or you can write, okay, I'm writing another step as well. Okay, fine. I am writing 1 minus 1 over 1 minus cos theta whole square plus sin square theta which is equal to 0. Okay. You may write 1 minus 1 or you can simply write 0. Because students often skip steps, so I don't think many students will be writing that step. You will be just writing 0. And it is perfectly correct. It is shown. Okay. So students, this brings us to the end of this question number 8 answer. And I'm Nilanjana Sanyal. I am an online IB math tutor. I tutor students from inside India and outside India. And I'm starting my group online math tutoring sessions. And I don't know when will this, I'll be uploading this video because I'm just recording it well in advance. But actually, I'm starting the group online tutoring sessions for IB Math A, SL and HL students. And you are seeing my email ID, you are seeing my WhatsApp number. If you are interested in joining my classes, they will be small groups. And if you are interested in joining my classes or if you are interested in knowing more about these classes, you may contact me. And thank you for staying with me till the end. We meet again in our next session where we'll be solving question number 9 of the same paper. So till then, bye.